we believe that applying deep learning to solving travel time problems actually opens up a slew of new opportunities. And one of the main reasons for that is speed and the ability to predict travel times at scale. So what we're looking at here is a web application that lets me visually explore and analyze travel times to new or existing store locations. So in my scenario, this is downtown San Francisco. I'm looking to expand my business to downtown San Francisco. So I'm going to go ahead and add a store here in the North Beach area. Now you can see my map updates. And what I'm looking at, in effect, you can think of as a travel time service. The colors on the map visually tell me how long it will take to get from anywhere on the map to this store, or really to the closest store. Now, to see what's happening a little bit behind the scenes, I'm going to turn off streets and turn on boundaries. And what we're actually looking at are census boundaries, in this case, census block groups, that are colored based off of the travel time. And these travel times are being calculated on the fly as I interact with my map. To visualize that, each of these pink lines from one of the census block groups to my store is being calculated in real time, and that value is used to determine the color. So I can essentially see a travel time service. So let me go back to streets. I can perhaps add another store, maybe here in the Richmond district, and I can see that as I interact with the map, it's visually showing me how long it takes to get to the closest store. I can also see in the lower left, it's providing me some metrics about travel time in my map. In this case, from anywhere in my map, the maximum travel time is going to be 65 minutes, and the average travel time will be about 20 minutes. Now, this is kind of a new, neat way of visualizing travel time, but it's not that different from what we've been able to do today. So what's different about the deep learning approach? Well, it kind of gets back to the speed, which allows me to do interactive real-time analysis. So in practice, a lot of you that are doing this kind of a planning workflow will want to incorporate demographic data. So I'm going to expand out this demographic chart, and now I'm able to see the total population represented in the map I'm looking at, as well as a breakdown by gender and by age. But more interestingly, we're able to determine the reachable population. In this case, reachability has a very close relationship with travel time. Populations that are closer to the store, that have a shorter travel time, are considered more reachable. And as the travel time increases, they become less reachable because customers are less willing to drive long distances or long times in the car to reach your office. So I can see reachable population as well as total. Now, maybe I want to explore this area in the Mission District. So I can add a little viewport here. And now I can see my chart only reflecting the travel time and reachable population and demographics within this viewport. And maybe I'll tighten this up a little bit, and I'll explore all through the Mission District here. And you can see as I move around, all my demographic travel time metrics on the left-hand side are updating in real time. Now, as a result of this analysis, maybe I've decided that I want to capitalize on some of that and move this store from North Beach down closer to the Mission. So I can select this store and drag it down, and as I drag, you see the chart and metrics update as well as the map. I'd like to remind you that when I'm dragging the mouse, all of these travel time calculations are happening in real time as I interact with the map. Now, because I'm able to do these travel calculations in real time, I can actually look at this at different days of the week and different times of the day. I think we intuitively know that travel time is dependent on time of day, especially in an urban area where Monday at 9 a.m., which is when I'm looking at this map, there's going to be a lot of traffic. So to highlight this change in travel time, I'm going to change my rendering here on the map so you can more clearly see exactly where that break is. We're going to set that to about 15 minutes. And now when I switch from Monday to Sunday, the map updates and the charts update because I can get further and I have more reachability on Sunday at 9 a.m. than I do on Monday at 9 a.m. So to date, so far, we've only been looking at a handful of new stores. But because we can do these operations at scale, I can bring in all of my existing stores, which I have here in a spreadsheet I'll bring into the map. This is about 230 stores in California. And as I zoom out, I'm able to look at the travel time surface to all of my stores and continue to zoom out and watch the metrics as well as the map update accordingly. And just to give you an idea of what's going on behind the scenes, we have some internal metrics here. If I expand this out, to produce this last map, when I zoomed out a little bit, it performed about 32,000 calculations in about 0.4 seconds.